This is sort of a review from yesterday. You had to get everything on one side. If you chose to do so, we have a difference of squares. We get x minus 4, x plus 4. Some of you chose to not do it this way and chose to take the square root of 16. But if you took the square root of 16, today we're going to really concentrate on, you're going to get a positive 4 and a negative 4 as your answers. In this case, x equals positive 4. In this case, x is going to be your negative 4. On the other hand, again, difference of squares. X and x, minus 11 plus 11. In order for this parentheses to be 0, x will have to be the positive 11. In order for this set of parentheses, x will be the negative 11. Today in section 5.3, the goal is to solve quadratic equations by finding square roots. It's just doing our warm-up in the shortcut way. We're reviewing an Algebra 1 topic about how to simplify radicals, and then we're going to solve quadratic equations by using the square root method. I'm just going to briefly discuss simplifying radicals. It's not one of our targets, but I think it's going to be necessary to cover so that way we can simplify the square roots nicely. So this is more like an Algebra 1 review. You could write it down or just watch. Simplest form of radicals is if you have no perfect square roots other than 1 in the radical. No fractions can be in the radicand. No fractions in the radicand. So you cannot have the square root of 3/5. You've got to rationalize. Because no radicals can be in a denominator of a fraction. So it's almost like you can't have fractions in the radicand because in a fraction that denominator technically has a radical in it. Cannot have radicals as a denominator. And we'll talk about how to rationalize. First 3 examples. To rationalize square root of 60, I'm going to put the work over here. You have to do the factor tree of 60 and realize, okay, 60 is, well, it's even, so it can be broken up into 2 and 30. And this is just one example. You could have broken up 60 in different ways. 2 and 15, I've got a pair of 2's. So this square root of 60 actually turns into 2 root, well, 3 and 5 are left, so 2 root 15. Another rule about radicals, if you have the square root times another square root, you can multiply what's part of the radicand. Anytime I say the word radicand, I'm talking about the stuff in the square root, inside the square root. So 2 is radicand, 18 is radicand, and their product is the square root of, we're looking at the square root of 36, which is just a 6. Number 3, square root of 81 over 121 can turn into broken pieces. Square root of 81 over the square root of 121, which becomes 9/11. So let's get to what we're doing. I just wanted to review radicals, and now this is what you're going to be doing. One of our targets is I can solve quadratic equations using the square root method. So 4x squared minus 5 equals negative 1. We're going to use the square root method. Square root method is to isolate the quadratic term, or isolate the x squared, and then take the square root of both sides. That's what we're going to do. We're going to isolate x squared. We'll take the square root of both sides and realize I'm going to have a plus or minus answer. Add 5 to both sides. You're left with 4. X squared equal to 4. You divide by 4 on both sides. So we've got x squared equal to 1. This is where the square root comes into place. I take the square root of both sides. And when I do that, I need to include, my answer is either going to be positive or negative. I'm going to get 2 answers. One's going to be positive, one will be negative. So x is either a positive 1 or a negative 1. I could either keep my answer like this or write it like this. 12 minus 2y squared equals 4. 12 minus 2y squared equals 4. We're going to solve the equation. When we solve this equation, the goal is to isolate y squared just as if it was a plain y. We're going to subtract by 12 on both sides and then divide by negative 2. It's at this point where you need to take the square root of both sides and realize when you take the square root of 4, you can either have a positive or a negative root. So this is going to be y equals plus or minus 2. So we're going to add 3 on both sides. And we've got p squared divided by 4 equals 36. To undo this division by 4, we're going to have to multiply by 4 on both sides. When we multiply, 4 divided by 4 is 1. We're left with p squared equals. So, when you take the square root, be sure you include the plus or minus. So p is either positive or negative 12. So, part of the square root method is what if we have y plus 3 quantity squared equals 9. This is a special case. It's one of the special cases. I still isolate the squared thing. Sometimes the thing is an expression. I need the parentheses now by itself on one side, which in this case it is. So this is an example of when taking the square root first is actually more helpful. If you take the square root on both sides, when we take the square root of this expression squared, we're just left with y plus 3 equals plus or minus 3. So to isolate y, we're going to subtract 3 on both sides. When we subtract 3, we still have to realize we had a plus or minus 3 on this side. Negative 3 plus 3, and then negative 3 minus 3 to find your two answers. So in this case, y is equal to negative 3 plus 3, 0, and y is equal to negative 3 minus 3, negative 6. So these are your two answers. Next example. We've got 2 times the quantity of x minus 3 squared, and that's equal to 8. Here's an example of when this set of parentheses being squared is not by itself. It's not isolated. I actually have to get rid of this 2. So let's divide both sides by 2. You're going to take the square root on both sides to get rid of that square, and you're going to include plus or minus. We need to add 3 on both sides, but we have to realize we're going to then take plus or minus 2. I'm going to get two answers. X is either equal to 3 plus 2, and x is equal to 3 minus 2. These are our two answers. So what if there's a fraction in front? If there's a fraction in front of a set of parentheses, we've got a fourth times the quantity b minus 8 squared equals 7. We're going to multiply by the reciprocal, multiply by 4 on both sides. This undoes that 1/4. But I've got a red flag. The 28 is not a perfect square, so I've got to have plus or minus. I'm going to have to rationalize that 28. 28 has a factor tree. We should get a pair of 2's. It becomes 2 root 7. And I'm still going to add 8 on both sides. I'm just going to leave my answer as a rational expression. Homework are the following 5 problems. 55, 57 on page 267. And then on page 268, these 3 problems.